Welcome to Get Your FRQ On. This question is from 2012, Calculus AB. It is question 4, and it is not calculator active. In the question stem, we're given a function f equals the square root of 25 minus x squared, which is a semicircle. It's the top half of a semicircle, and it is defined only for x values between -5 and 5 inclusive. And in part A, we are asked to find the derivative of f. Fairly simple differentiation. If f of x is the square root of 25 minus x squared, think of it like 25 minus x squared to the 1/2. Use the general power rule. We're going to get 1/2 25 minus x squared to the -1/2 times -2x. Have to use the chain rule here. And when we simplify that, we get negative x over the square root of 25 minus x squared. Right? But since f is only defined for values of x between -5 and 5, we should probably include that in our solution, that yes, this is f prime, but it does only work for values of x between -5 and 5. In part B, we are asked to write the equation of the tangent line to f of x at x equals 3. We did just find f prime of x, so we should be able to find f prime at -3. We just need to know f of -3. All right, so f prime at -3, if we plug that into the formula we found in part A, we get positive 3/4. Finding f of -3 is fairly straightforward. 25 minus 9 is 16, square root of 16 is 4. So we have x equals -3, y equals 4, and the slope equals 3/4. If we put that together in point slope form, we get y minus 4 equals 3/4 of x plus 3 as the equation of the tangent line to f at x equals -3. In part C, we are given a new function g of x defined as a piecewise function. G of x is equal to f of x when x is between -5 and -3 inclusive, and g of x is equal to x plus 7 when x is greater than -3 and less than or equal to 5. And then we are asked to determine if the function g of x is continuous at x equals -3 and provide justification. In order for g to be continuous at x equals 3, we have to show two different things. One, that the limit as x approaches -3 of g of x does exist, and two, that the limit as x approaches -3 of g of x is equal to the actual value of g of -3. Well, g of -3 is pretty easy to determine, since -3 is included in the domain for the top half of that piecewise function. G of -3 is simply the same as f of -3, which we already determined was 4. But if I want to know what happens when x is greater than -3, in other words, determining the limit as x approaches -3 from the right, we have to calculate that limit individually and show that that is equal to 4 as well. Well, if we calculate the limit from the left, g of x, we know that's 4 because that's just going to be f of x. All right, and if we approach -3 from the right, now we're using the bottom half of g of x, that's x plus 7. That limit would be -3 plus 7, which is 4. Notice that g of x has the exact same limit whether we approach x equals -3 from the left or the right, and that limit is 4, which happens to equal g of -3. So yes, g of x is continuous at x equals -3. For part D, we are asked to find the definite integral from 0 to 5 of x times the square root of 25 minus x squared dx. By first glance, it looks like this would be a good time to use u substitution. If we let u equal 25 minus x squared, then du is equal to -2x dx, and -1/2 du is x dx. And notice that x dx does show up in our integrand. right? So the integral from 0 to 5 of x times the square root of 25 minus x squared dx would equal negative 1/2 times the integral from u of 0 to u of 5 times u to the 1/2 du. Now u of 0 is going to be 25 minus 0, which is 25, and u of 5 will be 25 minus 25, which is 0, and notice that our upper bound is smaller than our lower bound. So we can fix this by switching their position in terms of the bounds, but remember when you do that, you also have to change the sign of the integral. Well, since the sign is originally negative here, if we switch it again, it becomes positive. So now we have 1/2 the integral from 0 to 25 of u to the 1/2 du. Using the general power rule for integrals, we're going to get 2/3 u to the 3/2 times that 1/2 in front. That makes 1/3 u to the 3/2, and we're going to evaluate that between 25 and 0. And when we do that, we get 125 over 3. So the integral from 0 to 5 of x times the square root of 25 minus x squared dx is 125 over 3.